So for numbers 1 through 8, well, first off, just numbers 1 through 5. We've got this original function over here. It's got a point here, a point there. It's not like a labeled as a point, but I mean that's a key point where you reach the maximum, right? So I'm gonna go ahead and think of those 5 points as my major points. Those look like we cross there. Yeah. We have like a quadratic shape and we have that. Okay. So domain is how far left and right the function goes. The farthest to the left it goes is -6. The farthest to the right it goes is 3. So my domain is -6 to 30 brackets. Range is how low and how high. The lowest it goes is -1, and the highest it goes is 30. So -1 to 30. On what intervals is the function increasing, decreasing, constant? So first, let's look at what the function is doing. The function is decreasing, but I remember that whenever I'm talking about intervals of increasing and decreasing, I'm looking at where, not the y values, right? So I know from -6 until -2, the function is decreasing. And then I know the function is now increasing until I reach x. It's tempting to say 3, but it's on the x-axis until 0. The function is increasing. And then from 0 to 1, I know my function is decreasing, so I've got another interval where I'm decreasing. And then I know from 1 to 3 on the x-axis, my function is remaining constant. So there's my intervals right there. First, I start off decreasing. So decreasing from -6 until -2. And I never use brackets on these because we don't need to, and then also because it would be incorrect at the points where we change. Then I'm increasing. So I'm increasing from 2 until 0. Then I'm decreasing again. I could have put the two decreasing terms together, but I would have wrote this, so I'm going to keep going. From 0 to 1, and then I know I'm remaining constant from 1 until 3. So there we go. Okay. What is the absolute minimum value of f of x? The absolute minimum value is the absolute lowest it goes, and that would be -1. Okay. What is the coordinate point of the absolute max? So the coordinate point of the absolute max would be at 0, 3. Now remember, whenever I do ask you, like, find the extrema, something like that, then you would want to say min of -1 at x equal -2. But in this case, I did just ask what's the minimum value, so the y value is fine. And the coordinate point is 0, 3 for that one right there. Okay. So for this one, it says describe or let g of x equal f of x minus 4. So that's just a shift to the right 4. So we're going to take this coordinate point, or this whole graph, and move it to the right 4. So right now this is at -6, 1, so it should be at -2, 1. Then I'm just going to use the relationship. I'm going to go down 2 and over 4. Down 2 and over 4 to get to the next point. Although I could have sketched the original one on here and just moved those points. I guess I did teach you to do that, didn't I? So what we did at the beginning was we sketched the original. With the dotted line. 0, 3. And then here. And then across there, right? So we sketched the original lightly with dotted lines. And then we moved it. So I'm moving the original to the right 4. So then I know this is at 0, so this would be right 4, that would be here at 3. And then, actually that's an important thing to think about. This is also what it goes through right there. So, and then this is right there. And then this is at 3, so it's the right 4 should be at 7. That makes sense. Okay. For some reason that looks shaping right here. All right. So taking the new graph, I'm going to answer these questions about it. What is the value of g of negative 2? So this is the function g of x now. So g of negative 2, which is what it's asking right here, is asking when x is negative 2, what's the function g at? And that is at 1. G of 4 is when x is 4, where is the function g? And the g is at 3. So there we go. And then it says, for what value of x does the minimum occur? So that's really important to think about what I'm asking. For what value of x does the minimum occur? I see the minimum occurs right here, and that occurs when x equals 3. Okay. Number 7, we've got a reflection over the x-axis. We've got a vertical stretch by a factor of 2, and we've got up 3. So this is going to be kind of interesting. I'm going to go ahead and sketch the original one on here, and then we're going to do the vertical stretch first. So, negative 6 of 1, negative 2, let's see, negative 4. So the original graph looks like this. Okay. First, we're going to vertically stretch it by a factor of 2. So I'm going to go, okay. So keeping in mind, this is a little bit interesting as far as how to apply it. Think about my y values. It's a little bit different when you're thinking about shifting first, which is what we do when we draw cubics and cube roots. We apply it to the pattern, but in fact what we're going to do is we're going to take this, and this is up 1, so we're going to go up 2. This is down 1, so it's going to go down 2. This is going to stay the same. This is up 3, so it's going to be up 6. And then this point right here is going to be, so this is up 2, so that's going to be up 4. And then this doesn't change because it's just a horizontal. Oh, yeah. Okay. So we vertically stretched it by a factor of 2. This was up 1, now it's up 2. This is down, now it's down 2. This is up 3, so now it's up 6. And this is up 2, and now it's up 4. Okay, I'm going to erase my original. It doesn't get confusing. Okay. So there is my graph so far with that. Now I'm going to reflect it over the x-axis, and then I'm going to go up here. So first I'm going to reflect it over the x-axis. Okay. Reflect over the x. So this is up. So we're going to go down 2. This is down, so we're going to go up 2. Sorry, somebody's on this in front. This is up 6, so we're going to go down 6. This is up 4, so we're going to go down 4. 4, and there we go. So this now looks like this. So there's my reflection. And then go up 3. So we're going to take this green function, and we're going to go up 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So my final answer is I'm going to go ahead and sketch it with a solid line. This is down 6, so 1, 2, 3, up 3, 1, 2, 3, 1, 2, 3, and then so my final answer should look like that. This is h of x. Okay, so what is the value of h of negative 1? H of negative 1 is negative 1. And what is the value of h of 1? H of 1 is also negative 1. What is the maximum value? So that's the y coordinate. The maximum value is the highest it goes, which is 5. And there we go. Okay, number 8. We've got our original function, and we've got some transformations active on it. So I'm going to go ahead and sketch the original real quick. Alright, can you guys tell me what I'm going to have to do in order to be able to determine the transformations of this function right here? I'm going to have to factor out that negative. Anything in front of the x, you're going to have to factor out. Good. So this is going to be f of negative, open parentheses, close, close, minus 3. So if you factor out a negative, this becomes just an x, and then a negative 2 divided by negative 1 is a positive 2. So in fact, it's a reflection over the y-axis, it's to the left 2, and it's down 3. Okay, so the first thing we're going to do is do the reflection over the y-axis, because the flips always have to go first. So we're going to reflect this, and that's going to put it, let's see, reflected over the y. So I've got my original one sketched, and I'm going to reflect this over the y-axis. Okay, this is to the left 6 and up 1, so we're going to do the right 6 and up 1. To the left 2 and down 1, so it's the right 2 and 1. Okay. These 2 points are symmetrical, so they'll stay the same. So like this point goes here, this point stays the same, and this point goes there, and then this point goes over here. So in fact, these just kind of stay there, but the side of it goes the other side. So I'm going to erase the original, so it doesn't get confusing. And if you want to, instead of drawing the original on there, you can just use this, the original graph, and then as you flip it, like sketch that on there. So there is my reflected over the y-axis. Okay, now we're going to do the next 2 things at the same time. We're going to go left 2 and down 3. So if I take this and go left 2 and down 3, so I'm going to take this point, go left 2, down 1, 2, 3, and then I'm just going to use the relationship they have with each other to sketch the rest. So I'm going to go over 2, I'm going to go over 1, up 1, and then up, down 1, and then I go down 1, 2, 3, over 1, 1, 2, 3, over 1, go over 2 and up 1, go over 2 and up 1. And there is my final answer. So that is W of X. Okay. What is the value of W of 6? So W of 6. So, hey guys, what do you think I do whenever it says, what is the value of W of 6? And here's 6. I need to know what y'all think. W is this purple function right here, and it's asking me what's W at 6. W at 6. Okay, it does not exist, right? W does not exist over there at negative 6, so I would say DNE does not exist. Okay, and then W of 3. So if I go over 3 down, this looks like it's down at negative 2.5, and that's true because it's a slope of up 1 over 2, so it's a slope of 1/2. So up 1/2 over 1. So it looks like it's at negative 2.5. Okay. What is the minimum value of W? The minimum value it goes is negative 4. Increase and decrease in constant. Okay. So first off, I know the function is remaining constant from here until here. That's from -5 to -3. So -5 to -3 for constant. You don't have to label them if you put them underneath what they go correspond to. Somehow I got to be able to tell them. The next thing I know is my function is increasing, and that is from -3 until -2. So -3 until -2 for increasing. Then my function is decreasing. So it's decreasing until x equals 0. So remember we're doing x values. So decreasing from -2 until 0. And then last thing it does is it increases again until we reach 4. So from 0 to 4 I'm increasing. So I'll just put that under there as well. So if you were to like do that, that would tell me which one is which. I'm increasing on these intervals, decreasing there, and constant there. Okay. What is the coordinate of the absolute maximum? The coordinate point of the absolute maximum of w of x is, it looks like -2, 0. So it's very much like that interval, but given the context of the question, I know whether or not you're answering a coordinate point or an interval. What's the domain of w? Domain is how far left and right. So it looks like the farthest left it goes to -5, the farthest right is 4. So -5 to 4. And the range is low to high. The lowest it goes looks like it's -4, and the highest it goes is 0. So -4 to 0. And that is the back page of the